that was fun. Here we go. Today, we are writing equations of oh, it's the 4th. My dad's birthday tomorrow. All right. So, writing equations of polynomial functions. I think this is my favorite thing. I've always wanted to do a project with a roller coaster, but I've never been able to put it together. But, you know, I think is it Cedar Point? I haven't been to Cedar Point since I was like 11. So they had the wooden coaster, right? Yeah. And the wooden coasters are cool because all they really do is go up and down, okay? You can't have a loop-de-loop, right? So what I love about these roller coasters is that they're really just portions of polynomials. And what's cool is I can take my roller coaster, and here I am in the little, the little cart trolley thing. There I am with my curly hair. Whee! Okay. I love roller coasters. Okay, so what I love is that I can imagine that here I can create this curve using math. All right, which I think is kind of fun. And so one of these days, I've never been able to get to it, but I've always wanted to. I want to say, hey, you know what? Let's do this. Let's take an axis and drop it on top of my lovely little roller coaster, right? So this is my XY axis. And what I've done now is I've created some really nice points, meaning these zeros, which are really useful because if I know all the zeros, I can use those zeros to build a polynomial. Because if I happen to know that this 0 is 1, where it's crossing the x-axis, then I have a factor, which would be x minus 1, right? And what I can do then is create a big long list of all of these bubbles and multiply them together, and voila, I've created this roller coaster. So I think it's pretty freaking rad, okay? So that's what we're doing today. We are writing equations of polynomials, which is not quite as cool as a roller coaster because we have to do more math. But here we go. Let's imagine for a moment that I have, well, let's do something more interesting. Let's do number 2. We want to write the equation that could represent a function with the given zeros. So these are the zeros. And so if I have a 0 of -7, from whence did it come? X plus 7. And if I had the 0 of -1, it came from x plus 1. And the 0 of 3 came from x minus 3. Okay, so what we need to do is we're actually writing this equation in standard form. And that's the tricky part today. Standard form means it's all multiplied out. Okay, so we got to multiply all of this together. And what I'm going to do is I'm going to start with the back 2 bubbles, and I need to FOIL those together. And so I have the x plus 7 is waiting its turn. I got to multiply these together. X times x is x squared. And the outside would be -3x. And the inside is plus 1x for a grand total of -2x. So I'm doing a couple steps in my head. And then last times last is -3. Okay, are you with me? Yeah. Okay. And then from here, we need to multiply these together. I'm going to go to the box method for this just to keep things nice and neat. I have my x plus 7 on the short side and x squared minus 2x minus 3 across the length. And we can multiply these together. X times x squared is x cubed. X times -2x is -2x squared. X times negative 3, negative 3x, 7x squared, negative 14x, and negative 21. And so I'm going to combine like terms. I have x cubed. Yeah, good. 7x squared and a negative 2x squared gets me that positive 5x. So that was like in stereo. That was pretty awesome. And then negative 14 and negative 3 is negative 17x, and then the minus 21. So here is our polynomial in standard form. Okay. Well, that's the easy one. Okay. So the other thing that happens is we get things like zeros. Well, these were all nice. These were all nice, rational, nice zeros. Okay. We're not going to multiply this one together, but let's just set this one up. I have a 0 of negative 2, which means it came from what bubble? X plus 2. What about negative 4/3? What bubble did that come from? 3x plus 4. 3x plus 4. So I would subtract the 4 and divide by the 3. Okay, yes, good job. Okay. Are you good with that? Yeah? All right. And then the last one would be x minus 2. Which ones should you multiply together first? They have the x plus 2 and the x minus 2 are great ones to multiply together because there's a pattern there. Okay? So it's important to look for that. We want to make it easy on ourselves. I'm not going to do any more work on this, but look for patterns is the key here. Look for a pattern. X plus 2x minus 2 multiplies together and cleans up real easy. Okay? So it gets a little more challenging for something like number 5. So we're going to do number 5. All right. Here we have a 0 of positive 2 radical 3. So what bubble did it come from? X minus 2 radical 3, and then x plus 2 radical 3, yes. And then we have plus or minus 1, so what bubbles for those? Yeah, x plus 1 and x minus 1. Good. All right. So 4 bubbles because we had 4 factors. Now again, we're looking for patterns, and so because these are the sum and difference, they're gonna multiply together real nice. So again, we're going to multiply these two together. So we're going to FOIL these together, and we're going to be so careful here. Let's see. First times first is x squared. The outside is 2x radical 3. Yeah, 2x radical 3. And then what's the inside? Negative 2x radical 3. Okay. And what happens with positive 2x radical 3 and negative 2x radical 3? Yeah, they cancel each other out. And that's why that sum and difference pattern is really nice. Okay? And then last times last. Oh, boy. Negative 2 radical 3 times 2 radical 3. What happens with that?
Radical 3 cancel out.
So here, they're all multiplied together. So I can rearrange at will. I can do negative 2 times 2 and then radical 3 times radical 3 because they're all just multiplied, yeah? Okay, so negative 2 times 2, ooh, multiplying. Negative 4. What's radical 3 times radical 3? Yes, just 3, good. So yes, radical 9, but that simplifies to just a 3. And so last times last turns out to be negative 12, all right? So being very careful, this is why we had to, we did that whole unit on multiplying radicals, all right? But yeah, negative 2 times 2 is negative 4. Radical 3 times radical 3 is 3. And then that cleans up. Now, on the tail end here, the pink bubbles, if you FOIL those together, what do you get? X squared minus 1, yes. Again, the negative 1x and the positive 1x cancel out. And now we just have to multiply these together, which isn't so bad now. And so we're foiling these as well. First times first is x to the fourth. The outside is negative x squared. The inside is negative 12x squared. And last times last is positive 12. And so we can combine like terms. X to the fourth minus 13x squared plus 12. And there's our polynomial in standard form. So really paying attention to patterns is super important. Now, let's see. Let's look at number 6. Number 6. So if I want to set up my bubbles, x plus 6 is the first bubble. X minus the whole 2 plus radical 5. Are you with me? All right. And then what's another bubble? Okay. X minus the whole 2 minus radical 5. Okay. Being very careful. We're subtracting the entire thing. I want to go one more step and distribute this negative, which you might be able to do in your head. Okay. I'm going to distribute my negative. That's going to give me x minus 2 minus radical 5. And then I get x minus 2 plus radical 5. Okay. There is a whole unit, a whole like Common Core standard in math that is paying attention to structure, okay? And so this is what I think is probably the trickiest part here. Oh, that's fascinating that she did this way. All right. She didn't really pay attention to structure. We have an x minus 2. I'm trying to think what's the best way to do this. All right. I don't like this question. All right. I'm going to leave the x plus 6 for a moment. Well, a long moment, actually. And we're going to multiply these bubbles together because if you'll notice, we have this thing. The first thing is at x minus 2. And then you'll notice we have the sum and difference pattern, a negative radical 5 and a positive radical 5. So this is that same sum and difference pattern. And what I'm going to do is very strategically multiply these together. And if I FOIL, I would do first times first. Well, that's going to be x minus 2, and it's going to be squared. And when I look at the outside now, I have this x minus 2 thing times the radical 5. What's the inside? But negative, yeah. So, yeah, it has the negative radical 5. Yeah, so they cancel out. So the outside, I'm going to write it down for you just so you can see. It's the radical 5 times the x minus 2. And the inside is negative radical 5 times the x minus 2. And again, positive radical 5x minus 2 and negative radical 5x minus 2 cancel each other out because they're that sum and difference pattern, which is kind of interesting. Okay? And then I just have to do last times last, negative radical 5 times positive radical 5. Which is what? Negative 5. Okay, are you with me? Because that's tough. Does that make sense to you? Like, are you seeing what I'm seeing? A little bit? We've never seen this before, have we? Like, this is the first time ever. Yeah, okay. Okay. Now, x minus 2 quantity squared. See, when I teach algebra, my algebra students can multiply this like that. X minus 2 times x minus 2. If you FOIL that together, what do you get?
X squared minus 4x.
Good. Very good. Okay. So now we have x plus 6. And then on my pink here, I have x squared minus 4x plus the 4 and minus 5. Negative 1. Yeah? Okay. So x plus 6, and then this becomes x squared minus 4x. 4 minus 5 is negative 1. Oh, gracious, these take forever. Okay, then what do you have to do? Multiply those together. Do I need to do that step? I would make a box. You don't have to, but x squared minus 4x minus 1, and then I have x plus 6. All right? X plus 6. Did I say minus? I'm sorry. Oh, you can't see that. There we go. All right, so if I did that, x cubed minus 4x squared minus x plus 6x squared minus 24x and minus 6. Lord, so much. Equals x cubed plus 2x squared minus 25x minus 6. All right, so that's really tricky paying attention to structure like that, but it does really help make things go a little quicker. Okay, so turn the page. Number 10, we have multiplicity 2. What did that mean when we had multiplicity 2? There's 2 of them, yeah. So if I were to set this up, I'm not going to multiply this one all the way out because I want to get to the i's, which is more interesting. So if I have a 0 of negative 1/2, what bubble did that come from? Yeah, good, 2x plus 1. And you said if it's multiplicity 2, there's 2 of them. I could put a power of 2, or I could just write it 2 times, which I think is helpful. And then, if I have a 0 of 4, what bubble did it come from? X minus 4. And again, the multiplicity 2 means there's 2 of them, all right? And then, how would you want to multiply these together? The pattern, yeah, we'd multiply. Now, is this the sum and difference pattern? No, it's not. Okay, but, so definitely because they match, it's easier to multiply those together first. And you will go on from there, and I'm not going to do that because I don't want to waste our time. Okay, so then, complex zeros. The conjugate root theorem says if a polynomial function has a complex zero, a plus bi, again, they're just placeholders for other numbers, all right? So 3 plus 2i or 3 minus 2i. Then its conjugate a minus bi is also a 0. So they love giving questions like this that, hey, one of the zeros is 3i. And what you have to know is that i's always come in pairs. Just like things with radicals, they come from the quadratic formula, which has the plus or minus always involved. The same is true when we get i's. We will never get I by itself. It always comes in opposite pairs, plus or minus. And that's what you need to know. Oh, it's only been 20 minutes. Can you believe it? I feel like this is taking forever. Okay. Let's look at number 13. If we want to write the polynomial, I have the 0 of 2 radical 5, and here's my function. All right, what bubble did it come from? X minus 2 radical 5 and x plus 2 radical 5. Yeah, as long as they're opposites, one positive, one negative, okay? Now, we have a negative I. Is it ever just by itself a negative I? No, there's also a positive I. They always come in conjugate pairs. So I have a couple of bubbles here. What are those bubbles? Yeah, x plus I and x minus I. Yes, they always come in pairs, and that's super duper important. All right, so I want to FOIL these things together. Let's see. So in my teal color here, I have x times x is x squared. What happens with the outside and inside? They cancel out. God, that's nice. And then last times last is going to be negative what? 2 times 2 is 4. Times 5. 20. Negative 20. So again, 2 radical 5 times 2 radical 5. We can multiply the 2's together to get the 4. And radical 5 times radical 5 is just 5. So we get 20. And the maroon, multiplying that together, we have x times x is x squared. Minus I, positive I cancel out. And then we get negative, what did you say, Rhodey? Negative I squared. Very good. Aha, good. If I is the square root of negative 1, what's I squared? Is it 1 or is it negative 1? Negative 1, yes. Getting rid of the radical, we get a negative 1. So I'm just going to clean that up. We have x squared minus 20, and this becomes x squared. What's I squared? Yeah, so this whole thing is negative 1. Yeah, it's minus the negative 1, definitely going to turn to a positive 1. All right, and from there we can FOIL that out pretty easily. So we get f of x equals, let's see, first times first is x to the 4th, plus 1x squared, minus 20x squared, which is negative 19x squared, and then negative 20. Yeah? Okay. So looking for patterns is very cool. We're going to practice one more time on number 14, because these are the hard ones. That was an easy one. All right. So I want to give myself some more space. So I'm going to write it up here, because the last one was very tough here. We have a 0 of negative 4, and we have a 3 plus I as the zeros. So I'm just moving it up a little higher. Now, so we have 3 plus I is never going to be by itself. What's the other 0? 3 minus I also. Always, always, they come in plus minus pairs, okay? Where the plus or minus is right in front of the I term, whatever that happens to be. All right, so if I want to write my polynomial bubbles here, I have my x plus 4, and then x minus the 3 plus I, and x minus parentheses the 3 minus I. Now you can skip a step here, but I like to show this is proper math here that I'm teaching you. So you have x plus 4. If I distribute my negative, that gives me x minus 3 minus I, and distributing the negative, x minus 3 plus I. All right, are you with me? We good? Yeah? All right, what do you notice with these bubbles here at the end? What do they have in common? They both have an x minus 3. So I'm going to just sort of highlight that so we can set it off. They both have that in common, that x minus 3. And then it's a plus I and a minus I. So that is the sum and difference pattern. All right, so we have x plus 4 in front, waiting its turn. And if I'm foiling these last two bubbles together, this is this pink bubble times x minus 3 times x minus 3, which is just minus. Yes, you could go there. I'm gonna hold on to that though. So x minus 3 quantity squared, because there's two of them, we're multiplying them together. And then what happens with my outside and inside there? Okay, and those will cancel out. And then, yeah, we have negative I times positive I, which would be negative I squared. All right. And yet that negative I squared is negative 1. It is going to turn to a plus 1, yes. All right. So I have my x plus 4 just totally waiting. And in pink here, x minus 3 times x minus 3. How does that FOIL out? Plus 9, good. And then we had the minus a negative 1, which becomes plus 1, yes.
And that would go with the 8.
And yes, now we can combine that 1 and the 9 together, yeah. Isn't this exciting? It's so horrible. Ugh. All right. All right, so we have x squared minus 6x plus 10. And then we got the box again. So x squared minus 6x plus 10 and x plus 4. And I'm just going to tell you the answer. X cubed minus 2x squared minus 14x plus 40 is the final answer. Do you have questions for me? This is hardcore algebra skill. There's a lot going on there. All right? Is it daunting, or are you like, well, that's boring? I don't know. I actually don't have any idea.